This is Algebra 2, Chapter 4, Section 3, Solving Quadratics by Square Roots. So you should have just completed homework number 2 in your homework packet. That was solving quadratics by factoring. So let's take a review from Algebra 1. We're going to review radicals. A radical is any expression with a square root, cube root, or etc. So a radical symbol is the square root symbol. So next we're going to list the first 20 perfect square roots. Go ahead and pause the video and take time to list the first 20 perfect square roots. When you're ready to continue and you think you have them, go ahead and push play. So you should have had the first 20 perfect square roots are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, and 324. So let's next move on to simplifying radicals. So we have two different cases here. Case 1, if we have perfect squares. So if you have perfect squares, we're going to take the square root of the number. Case 2, non-perfect squares, we're going to break the radical down using the largest perfect square under the radical within that number and take the square root of that perfect square and leave the leftover under the radical symbol. So what that looks like, we'll break it down here for you soon. In both cases, if there is a coefficient outside the radical, multiply this with any number you take out. Next, we are going to do some review practice. So we have the square root of 49. We know that 49 is a perfect square, and 7 times 7 equals 49. So the square root of 49 is going to be plus or minus 7. We have the square root of 225. 225 is also a perfect square, where 15 times 15, or 15 squared, equals 225. So the square root of 225 is going to be plus or minus 15. Next we have 2 times the square root of 144. So 2 is outside the radical, and 144 is under the radical. So the square root of 144 is 12, and then we take that times 2, so 2 times 12 equals plus or minus 24. Next we have the square root of 4 over 9, or 4/9. When we take the square root of each number, so we take the square root of the numerator, which is 4, so the square root of 4 equals 2, and the square root of the denominator, which is 9, square root of 9 is 3, so we have 2 over 3. Next, at number 9 on your note sheet, we have 5 times the square root of 72. So 72 is not a perfect square, okay? So what we need to do in case number 2, it says when we don't have a perfect square, we break down the radical down using the largest perfect square. Then we take the square root of that perfect square and leave the leftover, so whatever's left over, under the radical symbol. So the largest perfect square in 72 would be 36. 6 times 6, or 6 squared, equals 36. So 36 times 2 equals 72. So since 36 is a perfect square, we know that the square root of 36 is 6, and 2 is not a perfect square, so we would leave 2 under the radical. So we have 5 times 6 times the square root of 2. 5 times 6 equals 30, and then we have square root of 2, or the leftover, left under the radical symbol. So our answer is plus or minus 30 times the square root of 2. Now, on that page, I want you to do the rest on your own for practice. You can go ahead and pause this video and just work on that. When you're ready, go ahead and push play. The answers for the remaining problems should be number 5 plus or minus 1/9, number 6 plus or minus 6 over 11, number 7, 4 times the square root of 7, number 8 is 7 times the square root of 5, number 10 is 27 times the square root of 5, number 11 is 5 times the square root of 10, and number 12 is 51 times the square root of 2. If you didn't get some of those answers, go ahead and kind of relook at your work and take a look and see where you might have went wrong. Next, we're going to solve quadratics by square roots. Quadratic equations of the form ax squared plus c equals 0 can be solved using the square root property, which is if x is squared equal n, then x equals plus or minus n. So the steps of the square root property, the first step is we want to isolate that x squared. We want to take it and make it be by itself. Second step is take the square root of both sides. Next, we're going to simplify the radical, place plus or minus to indicate both answers. Because if you have a square root, it could be plus or minus the square root. Because if you take 12 squared, negative 12 squared is going to still equal positive 144. So examples from on the next page in your notes are x squared minus 64 equals 0. So we're going to go ahead and separate or isolate that x squared. So we want to take negative 64 and add it to both sides. So we have x squared equals 64. Then we take the square root of x2 and the square root of 64. Square root of x squared equals x, and the square root of 64 equals plus or minus 8. Number 2, we have 7x squared plus 8 equals 15. So we're going to take 7x squared and we're going to isolate that on one side of the equal sign. Next, we're going to add or subtract 8. We're going to subtract 8 from both sides. So we have 15 minus 8 equals 7, and 7x squared equals 7. Next, we want to get x squared all by itself. So we're going to go ahead and divide both sides by 7. So 7 times x squared divided by 7, the 7's cancel out and we're left with x squared. And 7 divided by 7 equals 1. Next, we want to go ahead and take the square root of both of those. And so the square root of x squared equals x, and the square root of 1, since it's a perfect square, equals 1. Number 3 on your note page, we have 81x squared plus 5 equals 21. So we want to go ahead and get that x squared on its own, isolate it, begin the isolation process. So we're going to go ahead and subtract 5 from both sides. Once we do that, 21 minus 5 equals 16. And then we have 81 squared equals 16. We want to go ahead and divide both sides by 81. Get that x squared by itself. So x squared equals 16 divided by 81, or 16 over 81. Go ahead and take the square root of both of those. We have the square root of x squared and the square root of 16 over 81. So the square root of x squared is just going to be x. And then the square root of 16 over 81, we're going to put a radical sign over 16 and a radical sign over 81 and separate it. So the square root of 16 is going to be what? 4. And the square root of 81 is 9. Great. So we're going to be left with x equals 4/9. Now, can you try numbers 4 through 9 on your own? So go ahead and pause this video, and when you're ready, go ahead and push play after you've done the work. So after you do the work for numbers 4 through 9 on your note sheet, here are the answers. For number 4, you're going to get plus or minus the square root of 2. Number 5, you're going to get x equals 4 times the square root of 2. Number 6, x equals 2 times the square root of 3. Number 7, x equals 3 times the square root of 3. Number 8, x equals 2 square root of 15. And number 9, x equals plus or minus 4 the square root of 5. Now I want you to complete homework number 3 in your homework packet. And that is the end for the Chapter 4, Section 3, Solving Quadratics by Square Roots. Thank you.